Welcome to Shore, India's situational hazard ocean reporting engine. This platform connects coastal communities across India's 7,500-kilometer coastline for real-time ocean hazard monitoring and response. We are providing three roles: citizen, official, and analyst, as you can see. Now, each of these roles would determine your dashboard layout, available features, and data access permissions. Let's log in as a citizen right now. So as you can see, I've already created a lot of citizens and they are stored in my database. And this is one of the user that I'm going to sign in right now. So now you can see this is the official dashboard for a citizen. Now this is your command center for coastal safety. You can see as we have this location selector on top. If you can see right now we are only providing few of these locations. We'll later add more. If you change to, let's say right now we are on Chennai. If you change to Andhra Pradesh, you can see the layout of your page changes, and most importantly, the recent reports changes. The news related to that location would change. And let's now select one Chennai. As you can see on this dashboard, when you will select, you will be first provided with these few indicators. These matrix we have on total reports, which shows all the reports that have been generated in that location. We have verified reports, we have active hazards, and social mentions. Below that, we have a summary which provides immediate safety guidance, like as you can see, avoid shoreline and beaches until official or clear, and this would obviously be different for all the locations. Now, as we scroll down, we can see we have another section called report section. Now, this basically shows community submissions, which is color coded by severity. As you can see, the high waves reported in Marina Beach, it shows unusually high waves, and this is basically a description given by one of the user that reported this hazard, and we can see a lot of them right now. If I click any of these reports, it will show me a modal, which will have some essential details like the description of the report hazard and the title. Obviously, it will also have the small thumbnails of image, any attached. Right now there are no images attached, that's why it's showing no photos attached. On the below dashboard also will have exact location and the timestamp. Right now I'll show you a different report in which there will be images. For example, this one, as you can see, we have few images that are attached by the user. If I click on this view full details, it will show me the complete overview of that report, including these comment section as well. Any user coming on your report can comment on it and engage with the report so that it creates a full community discussion thread. Now, going back to the main page, you can see we have a section called latest news and updates, which have a lot of different categories like breaking, environment, disaster, local, weather. All of these news have been scraped over the internet, and it only shows the news related to the ocean hazards to your specific location only. If you click on any of these news, it will hotlink you to their own website. Now, when it comes to submitting a report, you can see there's an add button. If you click this, it will open this form called report ocean hazard. Now, this process is straightforward. You have to select your hazard type, let's say storm surge. You'll have to set severity level, let's say high. You have to provide description, detailed description. You'll have to confirm your location with GPS detection. As you can see, if I provide my location, it will automatically detect my accurate coordinates. You can also provide some images, any attachments if you have. Right now I don't have any attachment, but if you want, you can also upload up to 5 photos or videos for proper evidence. Now each submission instantly reaches the community coastal authorities, creating comprehensive early warning system. Now you can see we have another dashboard called live map. If we open this, you can see this live map which is implemented using Leaflet API. It shows hazard distribution across India's coastline using heat mapping and color coded pins. We can see the green indicates low risk, orange for medium, and red for critical situations, obviously. The heat map concentration along Tamil Nadu's coast help visualize regional risk patterns. Each pin also represents a real citizen report, as you can see. Clicking reveals an info card with hazard type, severity level, and description, and reporting source. This creates a living hazard layer for instant situational awareness across coastal sites. Now, on to another key feature that makes Shore truly accessible across India's diverse coastal communities, which is our multilingual support. As you can see, this drop down menu, Shore breaks language barriers into coastal safety with support for three citizens: English, Hindi, and Kannada. Citizens can switch languages instantly using the language selector, making hazard reporting safely information accessible to diverse coastal communities across India. We'll add more support for more languages later in the future. If I select any of the language right now, you can see the whole dashboard changes. The entire citizen would adapt to the selected language. Live metrics like total reports, active hazards, and social mentions display in the chosen language. Regional safety summaries, hazard descriptions, and recommended actions, they would all automatically translate, ensuring every citizen understands critical safety information regardless of their preferred language. For instance, a Kannada speaking fisherman in Karnataka can access all the features in their native language. If I click this button, you can say this is translated as well. The hazard reporting form would truly support all three languages. Citizens can select hazard types from all these different ones, severity levels, and write detailed descriptions in their native languages. This ensures accurate, comfortable reporting in the user's native language, improving report quality and community participation. As you can see, this drop down menu sure breaks language barriers into coastal safety with support for three citizens: English, Hindi, and Kannada. Citizens can switch languages instantly using the language selector, making hazard reporting safely information accessible to diverse coastal communities across India. We'll add more support for more languages later in the future. If I select any of the language right now, you can see the whole dashboard changes. The entire citizen would adapt to the selected language. Live metrics like total reports, active hazards, and social mentions display in the chosen language. Regional safety summaries, hazard descriptions, and recommended actions, they would all automatically translate, ensuring every citizen understands critical safety information regardless of their preferred language. For instance, a Kannada speaking fisherman in Karnataka can access all the features in their native language. If I click this button, you can say this is translated as well. The hazard reporting form would truly support all three languages. Citizens can select hazard types from all these different ones, severity levels, and write detailed descriptions in their native languages. This ensures accurate, comfortable reporting in the user's native language, improving report quality and community participation. Here on the analyst report dashboard, we can see city-wise summary cards. Each card shows the number of reports received, active hazards, and primary hazard type. This helps analysts quickly identify high-risk coastal areas, and analysts can also search for any city pulled directly from a database, making navigation faster and more precise. For example, Chennai shows 45 reports with high waves flagged as the primary risk. When the analyst clicks a card, more details appear below, including the location pinned on the map using the leaflet API, along with a breakdown of active hazards. From here, analysts can generate a detailed report. On clicking the Generate Report button, the system leverages our LLM model, which combines all relevant data like citizen reports, encoys maritime data, and scraped social and news content to produce a comprehensive risk assessment. Now, this report includes metadata like priority level, hazard types, and affected regions, along with executive summary, detailed analysis, data source and methodology, and recommendations and actions. Now, the analyst will act as a human in the loop. They can review the generated content, they can edit any details, and validate the recommendations. Now, these suggested actions, such as evacuation advisories, emergency services deployment, and communication alerts, are highlighted clearly. Once verified, the report is timestamped, logged, and forwarded to the official dashboard for authorities to take immediate action. Now, this is our analytics dashboard, providing comprehensive insights in all hazard reports across the platform. At the top, as you can see, we have key performance indicators. First of all, it is 1247 total reports with 15% growth from last month. The second one is the verification rate of 73%. The third one is areas monitored, which is currently 15. And the last one is 12 active hazards being currently reported. Now we come to the actual charts. The first one is our hazard trends by month, which shows monthly reporting patterns from January to June. We can see a significant increase in reports during summer months, with June showing the highest activity across different hazard types, including high waves, storm surge, flooding, and tsunami. Now, the second pie chart, the severity distribution one, it provides a clear breakdown of risk levels, with like 20% of reports being classified as high severity, 40% being as medium, 35% as low, and 5% as critical. Now, this helps prioritize resource allocation and response strategies. Coming to the next one, it is a scatter plot, which is basically showing reports by region. In this, we are providing analysis by showing hazard distribution across different coastal areas, with each point representing different report density. This geographical view helps identify hotspot regions that requires enhanced monitoring. The next one is daily activity trend line. This tracker shows report patterns over different time, indicating peak activity periods and helping us understand seasonal trends in hazard occurrences. The last and least, the recent activity summaries table. It provides a real-time log of all incoming reports showing date, region, hazard type, severity, report counts, and current status. For instance, we can see Chennai with 15 high severity waves that are currently being active, while Cuddalore has 8 medium severity storm surge that reports have been resolved. This comprehensive analytics view enables administrators to monitor platform health, identify trends, and make data driven decisions for coastal hazard management. Now, this is our last dashboard, which is called Social Monitor Dashboard, and it continuously scrapes social media posts related to ocean hazards using targeted hashtags and keyword detection. This real time feeds helps analysts stay updated on emerging situations and public sentiment. At the top, you can see we have keyword filters where analysts can search for specific terms like coastal separation, cyclone, flood, or earthquake. Now, this location filter allows analysts to narrow down posts by specific cities or coastal regions or focus monitoring. Now, as you can see, each scrape post comes with three key features. First one is the source button, which allows analysts to view the original platform and link where the content was scraped from. Second, the flag button, which lets analysts decide whether this post should be included in the LLM context for report generation or not, essentially curating which social intelligence gets feed into our AI system. And the third one is the save button, which allows analysts to bookmark important posts for future references. Now, all of this creates a very powerful workflow where analysts can filter relevant content, verify sources, control what data influences AI generated reports, and build a personalized reference library of critical and social media intelligence. Now, on to the official dashboard. Here, verified intelligence transforms into operational command decisions. This interface serves government officials, emergency response teams, and coastal authorities who need real time situational awareness for protecting India's coastal regions. Now, I have my details filled in. Let's sign into one. So, when you sign into the official dashboard, you can see we have three tabs. One is live risk, another one is official report, and third one is social monitor. So, right now, we are on the live risk. As you can see, this is a map implemented by Leaflet, and this map layers provide critical operational intelligence through some specialized overlays. As you can see, we have two layers. One is risk assessment. If I select the risk assessment layer, you can see these dotted points which indicate threat probability zones. The red dots represents higher risk concentrations, guiding evacuation planning and resource deployment decisions. If I deselect it and select the swell surge, this is a blue heat mapping which is available, which models storm surge propagation and coastal inundation potential, which is essential for emergency evacuation planning and coastal infrastructure protection across Indian maritime boundaries. Now, this is the another tab which is called official reports, where verified assessments from analysts are presented for official action. Right now, the overview shows 3 total reports, 0 pending review, 1 urgent reports, and 3 approved ones. Officials can obviously filter by status and priority levels and search through all the reports. The reports list display analyst verified assessment ready for official response. Each report shows severity, location, timestamp, and current status. For example, you can see high wave alert for Tamil Nadu coast is marked urgent and approved. If I click on any of the report, it opens a detailed interface showing the complete analyst assessment. The report displays structured sections including executive summary for quick overview, affected regions, hazard types for geographic scope, detailed analysis with technical findings and recommendations, with specific actionable steps for emergency response. Now, this comprehensive format provides officials with all the necessary information to make informed decisions about resource deployment and public safety measures. At the bottom of each report, you can see there are two action buttons. The first one is download report, which generates a PDF for distribution to emergency teams. And the second one is issue advisory, which opens the advisory creation interface for targeted public communication. After clicking on it, it will display linked report details, including ID, title, analyst, and affected regions. Officials can customize the advisory title and content, which automatically populates with the report's keys, finding, and recommendations. They can set severity level. They can also change the targeted location and also attach any supporting files if needed. Once published, this advisory appears directly on citizen dashboards in the specified locations, ensuring targeted warnings only reach those relevant coastal communities. This creates a seamless flow from citizen reports through analyst verification to official emergency response and public safety communication. Now you're looking at the show's mobile application, which will bring the full citizen dashboard experience to smartphones, ensuring coastal safety information is accessible anywhere, anytime. Right now on the login screen, let's sign in with one of the email. So this is the mobile dashboard interface. It features a location picker at the top, which will dynamically update all the content based on the selected coastal area. For example, if I change from Chennai to Vishakhapatnam, you can see that summary and the reports would change. This location aware functionality ensures citizens receive hyper local safety information which would be relevant to their specific region. You can see there's this plus button. If I click on this, it will open the report Ocean Hazard. And since it's a mobile app, it leverages smartphone specific capabilities for enhanced field reporting. Citizens would instantly be able to capture photos using the device camera. GPS automatically would detect your precise location, just like this, you can see. And touch optimized forms would make hazard selection intuitive with thumbly friendly controls. Now we have another feature as well, which is offline sync functionality with intelligent caching, which is critical for remote coastal areas with poor network coverage. Citizens would be able to submit reports, view cached safety information, and access previously loaded maps without interconnectivity. Now, here all data automatically syncs when connection is restored, ensuring no hazard information is ever lost. We have another interface called Live Map. Now, this would provide native touch gestures like pinch to zoom, swipe navigation, tap to select markers. This interface is optimized for one handed usage.